Hello, geometers. We are back looking at Venn diagrams that are probability Venn diagrams that show probabilities instead of showing set members. And that's a big difference. Sometimes the Venn diagrams look something like this, where you've got your set A, set B, and maybe set A is the numbers 1 through 10. And set B is, or let's say set A is single digit numbers here, and set B is even numbers up to 20. And so there in the middle, you have the things that are in both sets, both in set A and in set B. And in a Venn diagram like this, you have members of sets shown. That's what you're seeing, is you're actually seeing all the members in the place that they belong. Well, in a probability Venn diagram, you're only going to see one thing written in each portion of the Venn diagram. Like you'll see something written in the part of circle A that is by itself, and then something written in the part of circle A that overlaps with circle B, something written in the part of circle B that's by itself, and something that's written completely outside the circles. And all of those things are probabilities. And what they are is the probability of a particular piece of data or set member that is anywhere in here of being in that particular area. So altogether, they should add up to 1, because altogether, all of your possibilities are going to add up to 100% of your possibilities. And 100% is a probability of 1. So the situation, though, that comes up is that it can be hard to figure out where to put these things if they're not already in place. But I wanted to just point out to you how they relate. This part in here, where they overlap, that's where things are both in A and also in B. So it's and. So this is the probability of being in A and in B. It's the intersection or the overlap. Now, if I wanted to know the probability of being in A given that I'm in B, the given that tells me, okay, the ground rules are that it has to be in B. So that means only out of this circle am I thinking about. Probability of being in A given that I'm in this circle. Well, the ones that are in this circle, this whole circle that are in A, are this right here. So this is 0.1 out of the whole circle, and the whole circle is 0.5. Okay, so I wanted to show you how that works with the equation. In other words, the probability of A given B is 0.1 is the part of circle B that is also in A. Notice that it comes from this middle section that is the probability of A and B, the intersection. The bottom here, the denominator, is the probability of being anywhere in that entire circle, which happens to be the probability of being in B. So right there you have an equation, which is actually an equation that's always true. The probability of A given B is equal to the probability of A and B divided by the probability of just B. And likewise, let's flip this over, probability of B given A is equal to that probability of both of them, A and B. B and A is the same thing, over the denominator, the probability of just being in A. Okay, so those are some equations I can use as I'm trying to figure out what goes where in these Venn diagrams. So I wanted to give you some examples. Here's the first example. Okay, let's suppose that I have my Venn diagram and I have to fill it in myself. It's not filled in for me, and I am given the probability of being in A, I'm given the probability of being in B, and I'm given the probability of being in B given A. So here's the problem. This is not the probability of being in this entire circle. It's just, I'm sorry, I said that backwards. It's not something I can just write someplace because I don't know where to write it. It is the probability of being in the entire circle. So the 0.35 is this whole circle. So part of the 0.35 goes here. Part of the 0.35 goes here. I have to figure out what part. Same thing goes for this one. This is the probability of being anywhere in the circle B. So that 0.40, that's the probability of being here or here. So I have to figure out what these two pieces are. They will add up to 0.4 because altogether the probability of being in circle B is 0.4. Same thing with over here. These two parts will add up to 0.35 because the probability of being in A altogether is 0.35. So what I have to do is I have to use this other piece of info to help me figure out how these overlap. This says the probability of being in B, given that I'm in A, is 0.2. Okay, given that I'm in A says given that we're talking about out of this entire circle. So out of this entire circle, the probability that I'm in B. Well, the only part of this entire circle that's in B is right here. So it's the probability of being in here out of this whole thing. Now, that doesn't mean you can just put a 0.2 there. They're saying that whatever goes there over the whole thing is 0.2. In other words, this part is 20% of the entire circle A. 0.20 is 20. That's where the 20% is coming from. So 0.20 of the entire circle A is right here. So 20% of circle A, which is the same thing as saying 1/5 of circle A. Well, if circle A is 0.35, 1/5 of 35 is 7. So this is 0.07. The other way I could have gotten that is just multiply. If I want to know what 20% of 0.35 is, that's 0.2 times 0.35. And that'll give me that part right there. Okay, that goes with this equation here. Probability of B given A is probability of both of them together divided by A. This is the 0.2. And that equals the probability of both of them divided by the probability of being in A. Okay, so that's what I'm doing, is I'm multiplying these to get this. And that's how I get that the probability of being in both is 0.07. Notice that's right here. Intersection means and, so that's 0.07. You'll notice that as I'm doing this, I usually write a 0 in front of the decimal place over here because that's really how I'm supposed to write it. But in the picture, I usually tend to save space and not write that. So if I don't write that in the picture, it's not for any mathematical reason, it's just to save space. Okay, so now I can figure out what goes in this part of A and what goes in this part of B, because the whole circle A is 0.35. Okay, so 0.35 minus 0.7, that's 0.28. And likewise, the whole circle B is 0.40. 0.40 minus 0.07 is 0.33. Now, this is OR, probability of being in A or in B, and that's basically just, that's union, that's everything put together. So if I put all this together, 0.228 plus 0.07 plus 0.33, that gives me, let's see, 0.68. And so that tells me that the probability of being in either of these is 0.68, which would also tell me that out here is 0.32. The last thing I have to fill in here is the probability of being in A, given that I'm in B. This one right here. So given that I'm in B means inside this entire circle B. So what goes on the bottom is going to be the 0.4 from that entire circle, 0.33 plus 0.07. The probability that I'm in both, because it's this group out of everybody over here. The probability that I'm in A, given that I'm in B. So that's probability of A and B, which is 0.07. So 0.07 over 0.40, that's 7/40ths. And I think that's 0.175. Let's go ahead and keep to the 10th, to the 100th, sorry. So that's 0.175. I'm going to round it and say 0.18. And I've got everything I need. That was our first example. Let's do another. On this one, I gave you a little bit different info. You're given the probability of B, the probability of B given A, and the probability of A and B. It's really nice to be given this one first because this is one of the first things I always look for. What goes in the middle there? That's what that is. So 0.1 goes in the middle. So that makes it nice. I can start there. Then if I know that the probability of B altogether is 0.7, and I know that this part of B is 0.1, I can subtract and know that this part out here must be 0.6. No, I don't need to write that anymore. Okay. Let's see, what else do I have here? I have the probability of B given that I'm in A is 0.25. So given that I'm in A, just like last time, means this whole circle over here. So out of this circle, the probability that anybody in this circle is in B is 0.25. That's this part right here. So there's a 25% chance if I randomly pick anything inside the A circle that it will be in here. That means the 0.1 has to be 25% of the entire circle. Okay, 0.1 is like 0.10. 25% is like 1/4. So 0.10 is 1/4 of 0.40. So this whole thing has to be 0.40. Now I don't have to do that just in my head like that. I can figure it out with the equation. P of B given A is the probability of being in both divided by the probability of being in A. Okay, so I know this 0.25 equals this divided by, and this is the part we don't know. If I solve that equation, I'll get a 0.4 here. And that is telling me all of P of A is 0.4. For this to be 1/4 of all this, 0.1 is 1/4 of 0.4. So that doesn't mean a 0.4 goes out here. That means a 0.3 goes out here because it's all together that it's 0.4. So let's see. Now over here, probability of A given B, that means out of everything in the B, the probability that it's also in A, which is this part right here. So 0.1 out of not 0.6, but 0.7, the whole thing. That's 1/7. That's about 0.1. I think I calculated that wrong on my example. So 1/7. I actually don't have a calculator in front of me, so I'm using my computer. So you probably did it faster than I did. 0.14. Okay. Interesting thing about this one, if you want to know what the probability of being in A or B is, that's basically in either circle, you could just add these up, 0.3 plus 0.1 plus 0.6, that's a 1. So there's nothing outside in this one. I'm just going to say 1.0. Last example, and then I'm going to give you 3 just like these for you to try. Okay, last example, I'm given the probability of being in circle B, altogether is 0.5. The probability of being in A given I'm in B is 0.1. That's like saying 10% of circle B is also in that overlap with circle A. And last but not least, the probability of being in A or B altogether is 0.86. Okay, so again, what I said here, probability of A given B, says that this part, this is the A part given that it's in B. So this part has to be 10% of this whole circle. This whole circle is 0.5. 10% of 0.5 is 0.05. I'm multiplying these two. And then that gives me 0.45 for the rest of it. I could use the equation P of A given B is the probability of being in both divided by the probability of being in B. So in other words, this divided by this has to give me 0.1. I'm sorry, this divided by this whole thing, not by this. This divided by the entire thing has to give me 0.1. And I could just put that in here and this here and go ahead and multiply and solve my equation. If you don't believe me, let me do it for you. 0.1 equals P of A and B over 0.5. To solve this equation, I would multiply 0.5 times 0.1, and that's where I get 0.05. Remember, that's the intersection, the overlap, and so I'd write 0.05 here. All right, next thing is I need to figure out what the probability of being in circle A is. Since I know the probability of being in any of the circles, in other words, this number is A or B, comes from adding up all three of these pieces, then I can go ahead and add these two, which is 0.5, subtract from 0.86, and I get 0.36. And actually, I messed that up. 0.36 is what remains over here, isn't it? Okay, that's what I have for 0.36. That means the probability of being in A is 0.36 plus 0.05. So probability of being in A is 0.41. And last but not least, probability of being in B, given that I'm in A. That means given that I'm in A, and I'm always shading the same circle, aren't I? Given that I'm in A, what is the probability that I'm in B? That's this over the entire thing. So 0.05 over, and remember we just said the entire thing is 0.41. So let me check that. And if you have a calculator in front of you, you could probably do it quickly, more quickly than I can. And I get 0.12. So there is my answer. Okay, so I'm going to give you 3 practice problems that have very similar problems. And I want you to go ahead and pause the video. Try them all. Take your time. Come back to the video later if you want to. You could pause it or just stop it for hours if you wish. But here's the first one. And here is the second one. And last but not least, we have the third one. So those are my 3 practice problems. So I want you to try all 3 of them. So I'm going to go ahead and show them to you again in order. And you can do the problem. Go ahead and pause it. Do this problem. Then when you're finished doing this problem, unpause. Move on to number 2. Pause again. Do the problem. Go back, look at the examples if you need to. Pause. Work. Come back and try number 3. And here's your grand pause. Don't unpause or go past this point unless you want to start seeing answers. All right, here are your answers to number 1. Go ahead and see what you think about that. Go back and try to figure out where you went wrong if you did. Okay, so here are your answers to number 2. Check and see how you did. See if you need to rework something. And then go on and check your answers to number 3. I hope this helped. And if you have any more questions, I'm sure we're going to have more opportunities to do some problems together. And you can also ask me in the comments.